you can send it to exams@txexams.com, either one. So it's at Yahoo. This goes just to me, nobody else, but if you want to do exams@txexams.com.
And that's for what?
If you have test questions only, okay? So now if you have just a regular generic question, just send it straight through, contact electrictest.com or whatever. But if you've got a test question specifically that you're struggling with, or if there's a question in the book like you had on that one, put it in a email instead of a text. And on most text messages, you can just do an email address instead of a phone number, and it'll convert and send it by email. But it's txexams.com. txexams.com. Okay, we'll go through them real fast, but my whole point with is don't lose that piece of paper. And sometime before you go through the test, this is your homework assignment number 2. Is every one of those tables that's listed on that has been on a recent exam. Okay, and it doesn't really matter whether you're taking a journeyman test or master's test. The same tables apply. It's just what they're going to make you do with the tables, maybe a little bit more complex between one or the other, but it's still the same tables. If those tables are on that page, you would do yourself a favor to go to that particular table, highlight it, make sure you understand how it applies, what it does, and how to work it. Always use a ruler or straight edge, guys. If you're using a table value, especially back in Chapter 9 when you're dealing with Table 4 and some of the other tables in some of the other chapters have such a dense amount of material and they're spread all the way across the page. And there's nothing worse in the world than to know exactly how to answer a question, know what table it is you're supposed to reference, and then get the damn thing wrong because you just let your finger slip down as you're trying to slide across the page. So just use a straight edge, and you'll get a piece of scratch paper when you walk in with your name on it, and you can just double that over and use it if nothing else. So the top 2 in Chapter 1 are 110.28, 110.26. This is your enclosure types. You should have page numbers on all the ones on there, right? Okay. 220.12, 42, 54, and 55. All 4 of these we're going to get to in a minute. And then for the masters, 220.56, and you also need to add 220.44, which are not on your list if you're taking the master's test. So add 220.44 and 220. 56 already on there. And then 250.66 and 250.122 are really, really important tables. It goes back to the grounding and bonding we were talking about. We're going to do this real quick and then we'll break for lunch. When we're dealing with grounding conductors, we're dealing with, you need to have 2 erasers. Got 2 dry erase boards, I'm going to have to have 2 erasers because otherwise I'm going to walk back and forth all day long. So when we're dealing with grounding conductors, that's a whole different animal. What we're talking about is your grounding conductors. And even within a grounding conductors, we have 2 main classes, right? We've got the service grounding, and then we've got the branch circuit grounding. And those 2 are completely different mentalities as well. So the first one that we're talking about is your GEC, and they use that acronym just like that on the test. Okay? The grounding electroconductor system is which one of the 2? The service or the branch? Service. Service, right? And it's always based on a wire size. The next one is your EGC, and they're so easy to get confused because they're the same letters, they're just kind of mixed up. And this is your branch circuit size, right? And it's always based on what?
Breaker size.
Breaker size. It's always based on the protection, so your overcurrent protection device or breaker. Alright. The GEC table is 250.66. Turn to it real quick. If you don't have a tab for it, that's one that you ought to make a tab for. It's a fairly easy table to navigate through. It's always based on the largest ungrounded conductor size. So if I gave you a set of conductors, let's say you had a service that had 3 copper conductors, or if I didn't even tell you at all whatsoever, what would be my minimum size GEC in aluminum? So you just find the 3 out here, and be careful with this table and any table that you're dealing with, because a lot of times they'll give you a value that's right in the cutoff, right? So make sure that you're in it. And it does say that 2-aught or 3-aught would have a minimum size of what aluminum? Mm-mm. Number 2, right? Is what I said was aluminum, not copper. I said copper up here, but what I said for the GC was aluminum. Be careful of that. So it would be a number 2 aluminum or number 4 copper if you're pulling the same conductor material. Everybody see what I'm talking about? Okay. Now, what do you do if you have multiple parallel runs and you're trying to size your ground electrical conductor? Let's say that you had, say you had 5 sets of 250 kc mil copper conductors, 3-phase service. So 5 sets, running in parallel. How do you size your GEC for that? Okay. If you look right below the table under note 1, that tells you that we're going to take the sum of all the ungrounded conductors in one set. So I've got 5 conduits here. Within each conduit, I've got 1, 2, 3 250s, and I've got my GEC, which we're trying to determine the size. Sometimes you may have a 4th one if it's a 3-phase with a neutral side service. So you'd have 4 wires there, and the 5th one's the GEC. You would take the sum of all 3 of these ungrounded conductors here, which is 250, 250, and 250, a total of what? 750 kc mil. The lump of that would then be applied to the table. So you basically size it based on a 750 kc mil, which would put you at the second to the last bottom, and that would be a 2-aught copper conductor. So each one of these sets would then require a 2-aught copper GEC. Okay? Now, equipment grounding is your bare or your green colored wires. And that's under dot 122. It's the next table, a couple pages over. This one, in a nutshell, is there's a couple of rules there that have been abused over the years. And the first one, I think, is, if you have to increase your size wire for cases of, for purposes of voltage drop, if you look on page 124 under note B, it's 250.122B. It's on the right-hand side there. 250.122B. What does it say right there?
Increased size shall be increased in size proportionally according to the circular mill area of the ungrounded conductors. Where ungrounded conductors are increased in size.
Enter B. Alright, so what they're saying here, guys, is that, let's say, and this is a perfect example, just happened to me about that story I was telling you about that parking lot lighting circuit. What was in that conduit, it was an 1 1/4 conduit, by the way. I had 8 sets of number 6, and I had 1 number 10 ground. Okay? The overcurrent protection devices feeding this, I had a 50 amp, a couple of 30 amps, I had a 20 amp with a neutral, so it was 2, 4, 6, 8, and then of course I had number 10 ground. What size would I put that on according to this table? Forget note B. Let's just say you normally would just go by the table. Well, you'd have to take the group, which is 50 amps. Look at the table there. What's the cutoff for number 10? 60. So I'm actually okay with the number 10 as far as that size right there. But all of these conductors here, if I have to increase that number, let's say, what would I normally have for that 50 amp? Let's say it'd be a number 8, right? So I would normally put a number 8 in here for this 50 amp, but I've actually increased it to a number 6 because of voltage drop, right? So if I normally put a number 8 at 50, but what I've got in there is obviously number 6, so I know they increase those on this one right here, and especially these right here, to compensate for voltage drop. I have at least 1 step larger on my equipment grounding conductor under note B, right? So there, that's number 324, the word right. I really am trying to break my habit of that. So I have increased it from number 10. I'd actually have to put that at a number, what? What size ground electrical conductor would I have to have if I had to increase the phase conductors by 1 step? Number 8, right? So you basically would increase this table value by the same number of steps. And that, in a nutshell, that's grounding electrical conductors, equipment grounds. There's a few other questions that kind of come in and out, some of them under 250.118, but I've got them listed on a separate page. All your tables under 300 are all, I think, on your page there. I don't think we've added any of them or changed any of them. Under 310.15, B16, we're going to go through that here in a little bit, and that's going to have quite a few changes as far as the actual table layout. And then in chapter 4, we have a few. Again, you've got all those listed. This is your homework for tonight, guys, right there. You don't have to go through and write that down. Seriously, if you will have 20 minutes to go through these tables real quick on your motors, tomorrow when we go through the motors, it'll make it a lot easier for you, okay? So just take a few minutes tonight, just go through those tables, make sure you got them highlighted, make sure you know what page numbers they are. And I think, like I said, they're all listed on your handout there. We're seeing like your hazardous locations, the fuel facilities and bulk fuel storage under 514 and 515, if you look at those real quick. On page 425 and 426 and 427, actually it starts on, it's 426 and 427. There's actually two tables, articled back to back there that are almost the same way. You have the specific location here, and then you have an extended or more defined part of the actual location on the left-hand side or the right-hand side. And the two letters in the middle are your classification of that particular exact location. So, for example, if I gave you a remote pump located indoor that had a 3 feet above floor level, what would that area be classified at? And you'll see that there's a 2 and a 2 on both columns. I'm on page 426. On the left-hand side under remote pump, indoor, and actually the entire space within any pit would be a 2 and 2. So that's a division 2, zone 2. Now in chapter 5, on your handouts, I gave you a chapter 5 handout that in chapter 5, the hazardous locations is probably one of the hardest ones to understand, and so I basically made you a little chart up there that kind of gives you a feel for how the zones and classes relate to each other. And you'll see that at the top, the lower that zone number or the lower that class number or the lower the division number is, the more dangerous that material is.
Is that a new handout versus the last time? Why don't I have that?
So I wouldn't spend a whole lot of time, but this is a good basic recapture of the first 7 or 8 chapters in chapter 5, or 7 or 8 articles in chapter 5. And it's just an easier way to understand most of it. It's all of the most important parts of it and none of the details that tend to kind of confuse a lot of people unless you've done a lot of hazardous location work and industrial work or stuff like that. But anyway, that's how that table works. The only other zone question that I know of on a juryman test has to do with a commercial repair garage, okay? And if you think about it, it makes sense. If you have a zone of 18 inches to the floor or 18 inches to the ceiling in a commercial repair garage, you have a tendency to have either heavier than air fumes communicated as about 22 for conductors and 52 for branch circuit.
So his motor feeder would be wired?
No, motor circuit conductors right here. Part 2. That's going to be put wire right there, right? And then put dot 22, because that's the article it deals with. Dot 22, remember? That's for a single motor, right?
So that'd be 430.22, right?
430.22, that's correct, yeah. So if you put wire right here. Okay. And then on this side you put dot 22. Right above it you'd put fuse, breaker, that's going to be dot 52, right? Your motor feeder, short circuit ground fault protection, that's mains, remember? So under main, that's going to be dot 62. Okay. And overload protection, under part 3, that's going to be heat, dot 32. Your books were, oh, just.
So the main, the motor feeder, short circuit, and ground fault protection, or which one?
This
Yeah,
one?
Main, yeah.
Main dot 62.
Oh, okay, so in that part.
Yeah, it's dot 62, it's just your main breaker, main protection. It does. And heat's dot 32. 32A and 32C, okay? So put A and C as well, because remember you got a standard setting and a maximum setting, right? Both of those being maximum settings, but one's a standard, one of them's a maximum. All right, and then what else do we have? The thermal protection, that's not usually on the test. The feeder wire at the top, that's going to be wire and dot 24.
24?
Yeah, that's what it's going to be. The one on the very top then is going to be your feeder. Please use your erasers. There we go. Where'd my annotation go? Oh, we got, well, you got them all so far. This is going to be wire as well. And that's going to be dot 24. So 24, the feeder was 62. The circuit conductors dot 22. The branch circuit was 52. The overload protection is 32. A1, excuse me, A and C. And your rest of that's different. Okay? So 24, 62, 52, 22, 32, both A and C. And of course you've got wire, fuse or breaker, fuse or breaker and wire, and then heat. Okay?
What else can we use on this practice test? What book?
And here in a second, when I give them to you, you're going to have to clear everything except one piece of paper and a code book and calculator. That's it. Well, of course, pencil
Can we
and
take
pen.
some of that stuff in there?
Hopefully, going to give them the answers.
Huh?
So it will be before, where they can put their answers for the final.
Oh, gotcha. Good. So really, you don't need anything except your code book, your pen, and calculator. And then if you got some stickers in your book or something, I'm not going to say anything. I'm not going to check the book. Put my cowboy hat on. Oh, y'all are all fans, right? Right?
You're the only fan.
Oh, who said that?
I did.
What's your license number? All right, so, and then next to this side over here, next to that side over here, let's put some page numbers down just real quick. So on, next to the feeder, put page, let me see, the feeder's going to be page 317. So next to motor feeder up there, put 317. I don't have much space on mine over here. 317. Under the feeder short circuit ground fault protection, on mains that's going to be 325. Under your branch circuit short circuit ground fault, that's going to be on page 323. Excuse me. Your motor circuit conductors are going to be under 316. Motor overload protection, which is your heaters. I know it's kind of hard to read what I wrote there. Heat is what that is supposed to say. I can't write on my screen though, it's only the bad part. And then on the page number, the first one is page 319, and then the second one's going to be 320. So 319/20. 320. This should be it. Now your disconnecting means is going to be on page 330, no, excuse me, 330. So under the disconnect at the top, you can put 330. And what I would put next to disconnect, I would just write up here 115%. That's the only thing you ever need to know about disconnects. That within sight is, 50 feet, starts at 55. And really that's all, I mean, as far as, now, there's some caveats to that. Actually, put 80% and then put 115%. We'll talk about it in just a second. Okay? So what you've done is you basically made yourself kind of a little cheat sheet or whatever. So that's roughly the same thing as you got on page 5, but since it's in the article, it might be a little faster. So if you have another one of those extra little red dots, you can just put one there. And
What page is this on?
well, it's on page 310, yeah. You have all your parts and stuff kind of listed here as well. And I think that's the same as yours, except yours is at the top instead on the side like that, but it's still a really good reference. You've got your part 1 general, your wiring in part 2, your overload heaters on part 3, part 4 is your short circuit ground fault, and part 5 is your feeder short circuit fuse and stuff. Motor controllers and motor control centers, MCCs, disconnect means, and then down there you have your over 600 volts and your table values. Okay? Masters, you have one more table, 251B. So if you guys will look at that real fast, you have one question out there that has to do with a fire pump motor. Fire pump motors, the overcurrent protection for fire pump is going to be at the highest value you can set it at. And that's based on the LRC because you want it to run indefinitely.
What page is that?
It'd be 339, I think.
Yeah.
Let's see, your table values. You don't have tables written up there, is the only thing. So what you can do, to the corner at the bottom, just put tables or FLC. You guys hear me? So you can just put over the side here, just put tables. And then just put tables. T-A-B-L-E, excuse me. Table. You can just write page 337, 338 for you guys, and for y'all, you'll also have 339. And also for the masters, just in case you run across it, at the bottom of page 338, the table for your 3-phase under 250, if you have a 90% power factor or an 80% power factor, you take the table value. If it's 90% power factor, you multiply it times 0.9. If it's an 80% power factor, you multiply it times times 1.1 or times 1.25. That actually increases the FLA value to compensate for a decreased efficiency. Make sense?
1.1?
1.1 or 1.25. See what I'm saying? If the table value is only, let's say for a 2 horsepower motor at 480, it's 3 amps, right? Well, if you have a 90% power factor, it means it's using more power than it's actually producing by 10%. So really, you're going to run at the rated wattage of the horsepower. You're actually going to run over 3 amps because of that inefficiency in the motor. It's actually going to run at 1.10. It's compensating for that 10% efficiency. Okay. You won't have to use it in calculation, but they may ask you a question that has to do with power factor. Okay. And then on the on y'all for the page 339, which is your FLCs, your LRCs for motors. Design B, C, or D, they've already pre-calculated out your LRCs. So those three, if you had a 50 horsepower motor that's used as a fire pump, The rule on fire pumps is you want to select an overcurrent protection that can carry indefinitely this LRC. So what size would you put a 50 horsepower, 480 volt fire pump motor on?
Emergency, can I go upstairs?
Yeah. 50 horsepower. What size breaker for a fire pump motor? You catch what I'm saying here on this fire pump motor? It's a 50 horsepower, 40 volt, right there. 363. You have to carry indefinitely that 363, which means you're going to have to select a size larger than that 363. So it'd be, they don't have 375, so it'd be a 400 amp breaker. In other words, you damn near want the fire pump motor to melt down before it shuts off. Only thing you don't want it to do is set fire on its own self, and then that'd be kind of bad. Yeah. Layout wise, we were
Is
talking.
there fire?
Yeah, fire pump motor, that's right. Yeah, you might just write it down in the bottom there, just put fire pump motor, 50 horsepower, 480 volt, 400 amp breaker. That way if you have it, you have it. So you can lay out a motor, especially a group motor, you can have, a set of feeders with a main over here. Then you can have a separate branch circuit protection device, then also a separate disconnect and heaters, all, by itself like that. Or you can even just have just this part itself, just individually, period. Or you can have it as a set of feeders with multiple motors, each one having its own protective device. Or you could have a set of feeders with one main subset of feeders where you've got protective device, and then another protective device on individual motors as well. So there's a couple ways you can lay out group motors. But when we were talking about every time you have a single set of wires that go to a single motor, that's always going to be 125%, right? This up here would be the 125% of the biggest motor plus the sum of all others, okay? And then this set of protective devices on table 52 would always be sized just on that motor by itself. But the one up here for the feeder would be the one where we take the 250% of the largest motor, round up, add the FLA of the other motors, and then round down. And same thing here, if you had a fuse there, these two fuses would likely be the same size unless they have some other loads further down. If there's some other loads further down, then this feeder would have a different size based on what we did yesterday where you have the breakers, the receptacles and the outside lighting, that kind of thing. This feeder right here would be calculated all the way out with the sum of the non-continuous loads and any continuous duty loads that are further down there. And then this set of feeders here, which is just the motor loads, would be the .62, where we do the round up and the round down thing. And then individual motors there. So these feeders here would be sized under .24. These feeders here would be sized under .22. Okay? I think that's pretty much all you need to know on the layout of it. Got it? Yeah, come on now. And just a kind of a smaller picture of it. Again, breaker, feeders, individual branch over current device there. This tap roll here and this tap roll here are going to be different. A feeder tap is right up here, and then these are branch circuit taps. Okay, and this is usually where you have your 10% roll. Excuse me, right here is where you have your 10% roll usually, because this is going to be a pretty short run most of the time. These can sometimes be a lot longer, so they usually be a third the size of the feeder on taps like that, because they're going to be 15, 20 feet almost without fail.
Those
And
taps
then-
are Article 240, right?
Well, for motors, it's going to be under Article 430, and it's .20. It's .53D4, and then your feeder taps are under .28 on 318. Go and write that down real quick. If you look on 430.28 on page 318, what I just said is that when you look at that top part where it's usually a short run, that's your rule here. That's the 10 foot is 10% rule. That's on page 318 under 430.28.1. And then at least 1/3 that of the feeder under note 2, and then also having a capacity not less than the feeder conductor. So it could be one of the three. If you wanted to, you could just run a full-size tap, not worry about it. And then your branch circuit feeders, which we were talking about, either be 125%, or if you had a branch circuit that fed more than one motor, it would be under .53D, single motor taps. And there, even there, the 25-foot rule is still a third the size of the branch circuit conductor, so you still have the same 25 feet, 1/3 size. Okay? And then just a quick recap, heaters, you're going to use 32. It's a service factor of 1.15 or 40. It's 125% or 150% all of the motors, or 140 or 130. You got your 52 with your 300%, or under exception number 2, which always round down. And then HVAC, I would just write myself a note on page that has dot 52 on it, which is what page? You're looking right there under dot 52 is page 323. Right below or above or to the side there, just put HVAC. It's 175, 225. So the same type of protection we're talking about for a standard motor, in Article 440, when you go back into it, sizing your protective device for a HVAC motor is going to be 175% or 225%, both round down. That's just a quick note. So it's 175% or not more than 225. So it's just like the heater where you have a standard setting and a maximum setting. Both of them round down values. Same thing with HVAC, except that applies to breakers and any other kind of protection. So for HVAC, 175, 225, and that's it. All right, I'll give you a couple of quick test questions just to kind of sink them in, and then we'll turn you loose on your final. Get a short time duty 15-minute rated motor. Nameplate rated 25 amps. Now, normally you'd use the horsepower and FLC tables. They don't give that to you here, so you just have to use the nameplate. What size THW and copper conductors would you need to be sized under 75 degrees Celsius column? Does a short time duty rating, 15-minute rating, have anything to do with this question?
The short time? Yeah.
Yes, it does, right?
Yeah.
It does apply when we're dealing with wire. We're under 430.22E since it's other than short time duty. So all you need to know is 25 times what? For a short time duty, 15-minute rated, that's the first row. Was it the second column? 15 minutes? Yeah. So we're going to select, instead of using 125% like we would for a continuous duty, we're going to select 120%, right? Short time duty, 15-minute rated, 120, right? It's 15-minute rated, right?
Okay.
So it's 120% of 25 amps, which would put you at probably what, 30, 31 something? That'd be number 10.
Oh, never mind.
Yeah.
No, I was going
You were looking at the 50, yeah, 5 minutes. All right, a 25 horsepower 2A volt 3-phase. The nameplate temperature rises 50 degrees Celsius, assuming no special increases are needed for the initial starting current. Calculate the maximum rating required for an overload device. Now, looking at this is a heater question, right? Talking about overload, not overcurrent. Your overload has two tables. The first one, 32A, the second one, 32C. Knowing which one to pick, it tells you assuming no special increases are needed for the initial starting current, so that's your clue, your standard size is what we're looking for. Even though it says maximum, what they're talking about is the maximum under the standard setting. Okay? So going back to 430.32A1, now they don't give you a nameplate value for it, so all you can do is just take the table value. So you're going to have to go back to 430.250 because it's three-phase motor. Yeah, 430.250, and a has a 74.8, right? That times the value of what? What do we multiply that times? Look at the bottom there. The cheat didn't give you the answer. I know, right? 125%?
Oh, no, 1.15.
Why is it 1.15 instead of 1.25?
Because 50 degrees Celsius is more than 40 degrees Celsius.
That's right. 50 degrees. The second row there, which I neglected to say anything about, that second row is a 40 degrees Celsius or less value.
Where did that, where did?
32A1. So give me a page number.
318.
318.
319.
319?
Yeah.
Oh,
Yeah.
okay.
319.
More standard.
Yeah, anything 40 degrees or less. So it's 115 on the service factor or more or higher, and it's 40 degrees or less on the second row. Otherwise, it's all of the motors. It'd be 1.15, right? So 74.8 times 1.15 then gives you what value? 86.02, and there it is. It's the largest value to choose from on the example. So you just put option number 4 would be your answer. All right. Here you go. Single phase, 2 horsepower, 115 volt squirrel cage motor. What size non-time delay fuse is required for overcurrent protection? First thing I do, before I look at anything else, what exactly am I looking for? It's a fuse. Overcurrent protection, that's short circuit or ground fault. I know I'm going to be in dot 52, which is the table for breakers and fuses. Now, I need an FLA value. It's a single phase, that's on 248, so 430.248. Single phase is the first of the 2 tables.
24.
24.
So 24 then is my, so 24 then, from the FLA values on page 337, is it?
Yeah.
For single phase horsepower? Single phase 2 horsepower with it? Yeah, 2 horsepower. What am I going to multiply for a non-time delay fuse? So I go from page 337 to what page? 323. So I'm going from my FLA to my dot 52 table, and it's 300%. It's that very first type of protection on that first row there, times 300%. So you multiply 24 times 3, you get what? 72. So is that the answer then, number 1?
Yeah.
Well, it's an answer on the test, but it wouldn't be the right one, right? It wouldn't earn you any points.
Down.
Did it run down?
Why round down? Huh? Yeah, because there's nothing in that test question that tells you that you have any permission to use exceptions, correct? And because of that, you'd have to round down, and the next exercise would be 70.
Is this one of those questions you get with that little?
I would. I mean, in this case, at 72 amps, you're going to be close enough that 70 is pretty obvious that it's probably a breaker. But it's good practice to keep in mind that you'd then go back to page 91, double check your standard size breakers, pick the next lower size. Now, you can see real easy, I can get every one of those 4 answers depending on how I apply the exceptions. The calculated value is the top one. A lot of guys make the mistake of choosing 72 because that's your calculated value, and don't bother to go back and realize that we're talking about a standard fuse size, and they don't make a 72 amp breaker or fuse that I've ever seen. Okay, so make that get that out of your head. The second thing is round it down or round it up. If you have 72, if you had permission, then you would round that up to 75. Right, there's no 75, so you'd round it up to 80. So I could get those top three either by using just the exception or exception number
So if
one.
you had an exception there, you would run up to 80, right?
Correct. If they give you permission to use any allowable exceptions or permissions, then it would round up. Now, if it was the same motor and they told you had an initial starting problem with the current, or a problem with the initial starting current, what would you do then? What is that telling you?
Times 125?
How's what?
You multiply 72 times 125?
Mm-mm. How would I, if the question is the same exact question, but instead of saying it the way it is, they just added where you have problems with the initial starting current. What they're telling you then is you've got to use what? Exception number 2, right? That's kind of like with the heaters. You have your initial standard setting, but if you have problems with starting current, you go to the second one, right? Same thing here. We have the table values, but we also wrote in exception number 2, which is the 400, the 225, the 400/300. Remember those values you wrote down?
That's 400.
That's what that's for. So if that same problem says you had initial problems with the starting current, what you're going to do is instead of 24 times 300, you're going to do 24 times what?
400.
400, exactly. And if you multiply that out, that gives you what, 992 something? What does it give you? 24 times 4, yeah, 92? 96. Now, always, no matter what, under exception 2, you have to round down. So you then round that down to a 98. So you can see all 4 of those answers are valid. It just depends on whether or not you're reading the question and paying attention to it. And that's how easy it is for motor questions to get you twisted around. Your practice exams or your initial exams, I think you had 3 or 4 motor questions, right? Can I have a set of those pre-evaluation exams for you? I'll tell you what, motors are actually one. Listen, guys. On motors, guys, they're actually one of the easier ones to get. All you have to do is keep straight these round up and round down times. That's it. As long as you can remember what the tables are, where they're at, whether you round up or round down, motors are a snap. You don't even have to know what you're doing. I could train somebody that's never seen a motor to ace motor questions. That doesn't make me feel bad. But I'm basically giving you the same tools. All that stuff that you wrote down in the front, use it. It'll keep you straight. It'll keep you clear. And then when you get to the section that the page number that tells you should be on, then just pay attention to those arrows. That's what we wrote them down for, right? There should be no reason why you shouldn't get every single motor question right every single time.
Use that in the...
Use them, yeah. All that stuff. We didn't just waste a lot of time putting that stuff in there just because I wanted to blow smoke up your skirt. It really will help. I promise you. So, I know, right? Oh well. Okay. Kilt, if you want to call it a kilt, just to make you feel better. All right. The questions that you had on your pre-exam, you had one motor that was a 3-phase 208 volt, 20 horsepower, had a service rating of 1.15, has no trouble starting. What size overload protection should it have? What kind of question is that? What are you sizing for? That's right, and that's under which table? What page number would you find that on? 320, beautiful. All right. Now the service factor 1.15 with no trouble starting, what number would you use for that?
Exception 1.
No, that's not dot 52. I'm sorry, did y'all say page 323?
Yeah.
No, that's wrong table. Talking about heaters, overloads, right?
Overload.
Sorry, I jumped too quick at page number because I had too many people say the same thing. That's not a good thing. 319, right? No trouble starting means that you're in the standard setting. Page 319, that's going to be, for a service factor 1.15, what value?
125%.
125%, and then round up or down?
Down.
Down, exactly. The next one you had was what size THHN wire is needed to supply 120 volt 2-phase single-phase motor, should be 2 horsepower single-phase motor with a 45 degrees Celsius and a service factor of 1.10. What page would we be on for that one? What were they asking for? They're looking for wire, right? Does the service factor have anything to do with wire sizing?
No.
Absolutely not. Right? They put that in there just so that you'd be on the wrong page. If you'd been on the wrong page, if you were paying attention to a service factor of 1.10 and an ambient temperature rise of 50 degrees, what value would you use to size a heater? What value would you use the size of the heater for that same motor?
115?
115%, right?
15%.
So if you're sizing wire at 125%, if you're on the table dealing with where they're trying to put you, on the heater table, you're using 115% to size wire. You see what I'm saying? Wrong answer. I mean, it'd be there for you to pick, but it wouldn't be the one you want to use, right?
But what was the question?
The question said, what size THN wire is needed to supply 120 volt, 2 horsepower, single phase motor operating at 45 degrees Celsius with a service factor of 1.10. So the last part of that you would completely ignore because the service factor has nothing to do with wire size at all whatsoever. So you just simply take the FLA value, right, times what?
1.10.
No, for wire size is what? For, huh?
Can you, what was that again, the,
For the wire size, what percentage do we multiply for wire for a single motor? 125%. That burn that in your brain. A single wire for a single motor or a single branch circuit set of wires for a single motor, 125% of the table value every time, right? The only time that changes is if you have a different duty rating
oh, okay.
with a different time factor. That's the only time that changes. So an intermittent duty doesn't have anything to do with inverse time circuit breaker sizing, but it does have something to do with wire size. Vice versa, short time duty rating doesn't have anything to do with heaters, right? So make sure that you're not trying to put service factors and ambient temperature on wire size either. All right, and then you had, I think, one more, which was I thought there was one more. You may not have gotten to it. A set of feeders. And a set of feeders with 480 volt three-phase motors. Just write this down real quick. So it's a set of feeders, 480 volt three-phase. Each one of them has a tap that's 23.5 feet away. This is almost exact word for word, guys. It has a tap 23.5 feet away.
Set of feeders of 40 volt?
480 volt three-phase, all of them. You had a 25 horsepower short time duty, 15-minute rated motor, which, guys, it doesn't have anything to do with sizing well, it does have to do with sizing wire for feeder, so I gotta leave that in there. 25 horsepower short time duty, 15-minute rated motor. You have a 10 horsepower and a 5 horsepower. What size feeder would you need? So it's a 25 horsepower short time duty, 15-minute rated, a 10 horsepower and a 5 horsepower. This is that one we did an example of earlier. Well, instead of using 125% on this one for the biggest motor, you're going to use what?
20?
Where'd you get 115 at?
10.
On what page? Where'd you get 115%? Now remember, we have a table with duty rating, with a different duty rating than continuous duty. We have a table that's under dot 22E, right?
317.
What page number?
317.
317. So here wire does have something to do with this table. So because the largest motor is other than continuous duty, you're going to use the table value and then the sum of all other motors.
What was the short time rating now?
It was a 15-minute rated motor, so short time duty 15-minute rated, so it'd be 120%, right? Instead of 125%. Now, okay, sounds like a lot to keep track of, but after you do a couple of them, it's not. It's really not. Wire size is either going to be 125%, or if it's a different duty, it's going to be that table there, and then that's it. If it's a multiple group of motors, then it's the largest motor times 125%, or if it's an other than continuous duty, whatever the value on the table is, plus the sum of all other motors. That's it.
Anything other than wire, it's on the.
If it's wire, it's right there. Wire is going to be 125% or 125% plus the sum of the other motors. And then if it's a different duty rating, it's going to be the table value individually times FLA, or if it's the largest motor, it'll be the FLA, the FLA times the table value there under 22E. So what size feeder then would we have for that motor? Huh? 10? Number 10? I'll be a little bit bigger than that. So 100 and what are we going to use for the short time 15-minute rated? 120, right? So you take your FLA value. What what's the FLA value for that motor? Is 45? Or 145?
34. And 34 times 125, 120 MB?
Yeah, it was 25 horsepower, 40 volt.
40, 28.
Yeah, you'd be in the 460 column for 25 horsepower would give you
But
34.
So we need a 1 ounce.
Well, 34 times 120.
yeah, it's
And then-
40.8.
Go ahead.
40.8.
So 34, which is the largest FLA, times 1.2
25 horsepower.
and 40.8, and then add the sum of the other two motors, which was a 10 and a 5 on the same one. So the 10 horsepower then would be 14,
Only 1.6.
34.
and then the 5 horsepower would be 7.6. So 62.4. What you got?
Add 30.
2.4.
62.4. That's correct.
Add that.
So just think of it as a picture, and you got a branch, right? Just kind of a tree. You got wire, then you got heaters, then you got fuses, then you got mains or any other kind of overcurrent protection device, and then dot 72, which is another table, has to do with control wiring. So it's 22, 32, 52, 62, 72. They all end in 2s. I mean, it's real easy. 22, 32, 52, I missed 32. 22, 32, 52, 72, all in an order, like 62, excuse me, I missed the main. So 62 and 30, 72. Try it again. 22, 32, 52, 62, 72. Just like that, in that order, right? And so you just got to make sure you're in the right section for whatever it is you're sizing for. So first thing you do with a motor question, forget everything in it, but what exactly are you looking for? And once you get that in your mind, whether you're using the front of the article, where you wrote all that stuff down, or you're using the table of contents, whichever's faster for you. It might be faster to use the table of contents because you kind of keep your hand on one side while you're kind of flipping with the other one, and then you kind of refer back and forth. But identify what you're sizing, make sure you're in the right page number, and then just apply the arrows or the percentages or whatever we just put down. And I promise you won't go wrong. Watch out for exceptions, and that's it. All right, guys, you can go ahead and pass them out theirs, and they can get started. Make sure they're right down the times. Oh, wait, before you get started, I got one more last big tip for you. One last tip, I promise it's worth your time. Listen to me real carefully, guys. This is probably the best thing I'll give you all for the whole weekend.
What did you do this on Friday?
Well, you wouldn't pay any attention to me on Friday. When you go into this test center, guys, you cannot treat this like you treat a normal test, okay? Do not go in there and start with question number 1, open up your book, try to find it. Go to question number 2, flip around, try to find it, go to question number 3. I promise you, especially if it's your first time, okay, and you haven't had a lot of code experience, you're going to run out of time, flat out. You're going to catch yourself doing what everybody else does. You're going to get stuck on question number 15. You're going to lose track of time, and before you know it, you'll have 15 minutes invested on a problem that's worth 1 point and just run out of time on the stuff at the end of the exam. I don't know how many times I've seen guys come in here that just had 10 more questions at the end. They got through 70 of them, the clock ran out, or 90, or 70, or 80. And it's a terrible thing to do because, knowing if you have the luck like I have, those would be the 10 easiest damn questions on the test, right? So what you have to do is be real strategic about this test, okay? When you go in there, I want you to take that book, and I don't care how bad it hurts. I promise you, I've seen guys come through class, ignored what I'm telling you now, done it the way they wanted to do it, failed by a few points, go back in there after I beat them up for not doing what I told them to do and pass. I'm telling you, it will work. It'll help you with your time management. That's really what it's all about. Put that book underneath your ass if you have to keep you from opening it up. Start with question number 1 and go through the entire test. Just like that. Question number 2, question number 3, just so on. Just beat them through all the way down. All right? Don't spend a lot of time dissecting them, trying to think about it. I'm just wanting you to do either you know it or you don't. Simple as that. Either you memorized it, because we talked about some of those stuff yesterday, like the 18 inches, the 20 inches, and the 24 inches, and the 6 foot, and all that stuff that we did yesterday, right? If you guys run across one of those, you answer it. But if you answer it, don't ever go back to it, okay? If you know it and you feel confident about it, don't look back, okay? Stand on your own 2 feet. Even if it's wrong, I'd rather you do that than spend 15 minutes trying to convince yourself that you were, that you were wrong, when in fact you weren't wrong and you changed your answer and got it wrong anyway, right? All right. The ones that you know for a fact, you're going to answer them and do nothing else except hit the next button. And yesterday I showed y'all a table. It was one of the first things we did. Silly thing. It's one of the first slides I think I showed you. If I didn't, I'm going to show you now. And it's a screenshot of what you're looking at there in the test room. Yeah, it's almost there. Give me 2 more seconds. Oh, there it was. Right there. All right. When you go in there, you're going to have this same exact screenshot, just like that. And the stuff on the very top row, the mark the comments go to, most people have no idea it's even there or what it does. The second row, which is your black line, the only thing you pay attention to is that very last value, and trust me, that clock's faster than any clock in the whole planet.
Yeah.
You know? They put it on some kind of atomic accelerated time or something. But anyway.
Why did they put it there, man?
I know, right? Just to teach you to mess with you. All right, so you have your question across the top, question number 3. You have your answers down there. You choose whichever one's the best option of them, and you hit the next button, okay? But you got a couple of ways you can do this. This mark button up here is really, really important, okay? So you're going through that first run through, you got your book closed, you know a question, you mark it, you hit next, and that's it. Never ever go back, all right? Well, the trick is, how do you know which ones that you knew, and how do you remember which ones you thought you knew, and how do you remember which ones you didn't know? Well, ones you didn't know, you're just not going to answer them at all. If you don't know the answer right off the bat, or if it's a calculation question, or if it's a print question, I'd write those 3 things down, guys. Calculations, prints, and Greek questions, way I shorthand the knowledge. If it looks like it's written in another language, then you don't know what it is, skip it. Leave it blank. Just don't do anything at all, just hit next. As soon as you realize it's a calculation question, next. Next, next, next. Don't even touch it, right? Don't try to do math on question number 15, because you have no idea how much time you really have for that math question yet. Okay? Mm-hmm. Now, the second set, which is going to be the ones that you kind of think you know, or you have a good guess because it looks pretty obvious, but you still want to go back and check yourself later on, right? Those are the ones that you're going to take your best stab at. Now, those are different than the ones that you think you know. If you think you know it, don't do anything but just mark it and just hit next and don't worry about it. But if you have a good guess, educated guess, not just a wild-ass guess, a wag, but an educated guess, or you think you might want to know, answer it, but hit the mark button at the top. So that ends up with 3 separate, distinct categories. Ones that you know, pretty good sure of them. Ones that you have a pretty good guess at or think you might know but want to check on them. And then ones that you don't have any clue, or calculations or prints, right? Those 3 things, at the end of the test, when you go up here and hit this go-to button, a magic genie window comes up and says, okay, which of those 3 groups would you like to go to? And then you get to pick whichever one you want to be in. Which one would you go to at the end of the run-through? I'd go to the ones I didn't answer yet, because I already marked the ones that, at least I got a good guess at it. If I run out of time, at least I had the best chance I had to guess at it. So then if I'm one of those guys that ends up with question number 70 with no time left, at least the 10 that I didn't really look at, I had a chance to guess at them, or a couple of them I did, right? So what I'm talking about is go back to the ones you didn't answer at all. Those are the Greek questions, the calculation questions, the print questions, okay? Those 3, which you don't have any answer on at all, when you hit the go-to and go to the unanswered, it'll take you to the first one that you didn't answer, and then when you answer it, it automatically drops out of that category, and you go to the next, when you hit the next button, it goes to not the next question in a row, but the next one you didn't answer. Just that fact alone will pay for whatever time you invested in it. Because now you've got a distinct little group there that's got nothing in it but that one category. And you talk, just from time, think about it, just hitting next 100 times, and then hitting next, you're back 100 times, just going back and forth like that, trying to remember which ones you knew or didn't, you wanted to check or didn't know. My God, you spend more time doing that than anything. Just talk about a terrible waste of time.
So at the end of the test, you hit go to.
Hit the go-to. So you do your run-through, and guys, don't dissect the questions, right? You either know it or you don't, right? If you don't know it, fine. Can you guess at it? Then it gets answered marked. If you don't know it, you just skip it, okay?
We hit mark first and then mark it over there?
Well, you answer it, you know, down here,
Hit
you
mark.
just hit the mark button, yeah.
And then at the end, you hit go to,
Well,
and it'll
then
give
it'll give
you
you
go
three
to the
categories.
mark.
That's right.
or
There'll
go
actually,
to the
there'll actually be 4 categories. There'll be all, which is where you're at right now, and where most people stay in because they have no idea that there's a neat little trick up there for the go-to button, right? Or you'll have answered, marked, unanswered. So really the 3 categories at the bottom are what we're talking about. It's a beautiful way to take this test, okay? Because how many times have you looked for a question, like say you're on question number 82. Well, not for you guys, you'd be on question number 62, and y'all are on question 82. And you're looking for, you know, the maximum size or minimum size ground electrode conductor for a rod, which is what? What's the minimum size for a ground rod?
6.
Ground rod?
No, minimum size for, not the jumper to it, but the actual ground rod itself, diameter.
5/8.
5/8, right?
Oh, 5/8
See,
ground rod.
you guys know that. That's one that you should just answer and don't mark it, just answer it and never go back. There's no point in looking up a question like that, because if you could tell me that, do it the same way on the test, right? All right, now, you accidentally run across something you were looking for an hour ago and couldn't find it then, and there it is right there, just by pure accident. It happens to everybody in this room. It'll happen every time you take a test. It's called dumb luck, right? Dumb luck's always worth a couple of points. Well, if you're on question number 15 and your dumb luck kicks in, on question number 62, you've got no idea question 62 is even on the test yet. Now, when you get to question 62, you'll be kicking yourself because you go, man, I know I saw that and spent 15 minutes trying to refine what you accidentally found the first time. Okay? Telling you, as I'll stand in front of you, do what I'm telling you, and it will buy you at least 30 minutes on this test. I promise you. Okay? Yesterday we were talking about, well, I want specifics and I want this. I'm telling you, that table of contents tip, tagging your part numbers like I told you, using the tricks like we have with the page numbers on the motors and picking that first deal, and then running through this test and marking them like this, that strategy will buy you a lot of time that nobody else is going to have. Okay? And somebody said yesterday, well, if they gave me 8 hours, I could pass the damn thing. Well, that's exactly right. Sometimes it's about that time management. So, all right, now we've done all that. We've done the run through. We've gone to the go-to. We're now into the category, which are the ones that are Greek, prints, or questions are easy, guys. They're not that difficult. And I would do those first just to knock them out of the way.